Yeah, welcome to e-Pathshala lecture series in computer science. This class will learn about different components of an operating system. So, the objective of this class is to learn about the different components of an operating system and to learn about the different functions of each of the component of an operating system. So, if you look at the different components of an operating system, you have process management, main memory and secondary memory management, file and IO systems management, networking, protection system and command interpreter system. So, we will take each one of these and see what are the functions of an operating system with respect to each of these systems. So, first we learn about this process management. So, before getting into process management, what do you mean by a process? We all know what a program is. We all have written programs say in C, C++ or any other language. And what is actually a process? What is the difference between a program and a process? A program is just a file where you have a set of instructions written in some language. It can either be a high level language or an assembly language or whatever. And when you execute this program, say you compile this program and you run this program, you get a process. So, how is this process different from the program that you had written? So, when a program is in execution or when the program runs, it is called a process. In addition to the program set of instructions, you have lot of the more that comprise the process. So, in a process, you have say text, data and stack. That is, the instructions in the program, the set of instructions, they form the text part of the process. And in data, when you write a program, you will have some global variables given in the program, that those variables can be either initialized or uninitialized. So, this global variables form the part of the data section of the process. And what is meant by stack? Say when you have a program, you can have a number of function calls within the program. So, whenever there is a call to a function, the stack will be invoked and layer will be pushed into the stack. And the stack will have the local variables within that particular function, the arguments that you pass to the function and the return values that come from the function. So, all these will form a part of the stack. So, you have text, you have data and you have stack that form a part of the process. And in addition to these, you have memory management tables. That is, this program or the process that is currently running, say it is present in the main memory, then we need to know where in the memory this process is present. So, you need to have certain tables that will manage the details of all these. And very similarly, the process can even be moved to the secondary storage, and even in that case you need to have tables or you need to have data structures that take care of where it is present in the secondary storage and how much of space is occupied, etc. and so on. And this also form a part of the process. In addition to that, you have something called a program counter. What is actually being put into a program counter? The program counter will have the address of the next instruction to be executed. And when this process is running, the PC will have or the program counter will have the address of the next instruction with respect to this process which is to be executed next. You can also have something called the stack pointer which will point to the top of the stack. You can also have certain registers which will have values relevant to this particular process. So, all these put together comprise a process. Now, I think you can see the difference between what a program is and what a process is. So, a process is called as a program in execution. Now, with respect to this process, what are the functionalities of an OS? So, when you say that you have a process, the process will need a number of resources. It will need CPU time, it will need memory, it will need files, or it will open files, it will read from files, write into files, It will need I/O devices in the sense that it will write to the input, write to the output device, it will read from the input device, etc., and so on. So, with respect to processes, what are the functionalities of an operating system? So, the operating system is responsible for creation of any process, the deletion of the process. Say the process can be suspended for some amount of time and then can be resumed. That is, say the process is waiting for some input, say a process is waiting for input to be given from the keyboard. Then in that case the process can wait for some amount of time because the user may not give the input immediately, and during that time the CPU can be given to some other process. So, this process is made to wait, and after some time the process is made to resume back. So, all these are done by the operating system. And then when say there are many processes that are running in the system, the process may have to communicate between themselves, that is, the output of one process may be given as the input of the other process and vice versa. So, in that case process communication needs to take place. So, facilities for this are given by the operating system. And then you have process synchronization. This is like, say you have multiple processes, they are going to use a common shared resource. Say for example, a simple variable that is being shared between multiple processes. Then in that case, there needs to be some synchronization between the two processes who are going to access this common shared resource. So, this is done by the operating system. And then again, say when multiple processes they are using resources, say there are two resources which need to be used by say two processes, and if these two resources, say one of the resources is held by one process and the other resource is held by the other process, and both of the processes are waiting for the other one to be released, then in that case a deadlock happens, and these kind of deadlocks also have to be handled by the operating system. So, these are the functionalities that an operating system needs to handle with respect to processes. And then we have memory management. So, we saw what a process is, and this process when it runs, it will be present in the main memory, or any process during execution has to be present in the main memory. So, what is this main memory? This main memory is nothing but a large array of words or of bytes, and each byte is being addressed by its own address, and it is basically a lot of data, it is a repository of data, and this data is being shared by the CPU as well as the I/O devices. So, this main memory is also a volatile storage device. Say for example, the RAM is used as the main memory, where the contents are volatile. Once the power is switched off, the contents do not remain anymore. So, this main memory is the one where process has to be kept if they are under execution. So, this program that is placed into the main memory should be mapped onto the addresses of the main memory, and they have to be loaded into the memory. So, and when the process terminates, the memory space is freed and they are available for the next process. And to improve the speed of the computer's response to users, not only a single process is placed in the main memory, many processes can also be placed in the main memory. So, there are a number of main memory management schemes that are available that will take care of which process should be placed in the main memory and so on. And again, this is hardware dependent. There are many schemes like say paging, segmentation and so on, which do these to take care of memory management. So, now we will see what are the functions of the operating system with respect to memory management. So, the operating system will keep track of which process is in which place in the main memory, or which part of the main memory is occupied by which process, and it will also decide on which process should be loaded into the main memory. Say one process is currently occupying space in the main memory, and then the process finishes off or it terminates. Then the next process has to be brought into that particular space. The OS will decide which process will now come in that particular place, and it will allocate memory space, it will deallocate memory space as and when needed. So, we have seen about process management, we have seen about main memory management. Now, we will see about what file management or what kind of file management is being done by operating systems. So, what is meant by a file? We all use files, and files are being stored in secondary storage devices. So, a file is nothing but a collection of related information. So, you have files which represent programs, files which just store data, and programs in the sense it can be some source programs like C programs, C++ programs, etc., and so on, or it can even be just object code. And if you look at data programs, you can have numeric, you can have alphabetic, you can have alphanumeric programs, etc., and so on. So, all these are being put into files, and these files can be placed in the secondary storage device. And these files, rather than placing them just like that in storage devices, you can arrange them into a particular structure, so that it will be easier to retrieve files or to delete files, etc., and so on. So, this structure can be a hierarchical structure, in the sense files can be put into directories, and multiple directories again can be put into directories, etc., and so on. You can have a structure in which all these files are being maintained, and this is called a file system. So, the structure in which files are maintained is called a file system. And we also need to control who will access a file and in what ways. That is, the file can be accessed for reading, for writing, executing, etc., and so on. And we can have mechanisms, access control to decide on what file is being, how the file is being used. So, when you are looking at the functionalities of an operating system with respect to files, creation of any file or deletion of a file is done by the operating system, and very similarly creation of directories, deletion of directories are done by operating systems. And then you have different primitives for manipulating files and directories, in the sense like you can read from a file, write into a file, and so on. So, a number of operations can be done on a file. All these have support with the operating system. And then you have mapping of the files onto the secondary storage device. These files, that is, these files have to be stored in the disk. So, we need to have some mechanisms to say which file is placed in which part in the secondary device, and also we need to keep track of where each file is being kept in the secondary device. All these have to be done by the OS. So, appropriate data structures for that have to be maintained by the operating system. And file backup on stable storage media has also been an operation or the work of the operating system. And then we have IO system management. So, in IO system management, that is, say you have a number of IO devices, say you have the printer, you have the disk, you have the keyboard, etc., and so on. So, these IO devices are treated very similar to files by operating systems. That is, the peculiarities of the IO devices are hidden from the OS by the IO subsystem. So, you have something like device drivers that will sit in between the operating system and the devices, and they provide support for the IO management. So, if you look at this IO subsystem which sits between the operating system and the IO devices, it takes care of, say, buffering, it takes care of caching, and so on. Say for example, the IO is slower, say the input that you give from the keyboard is slow, then this input will be stored in a buffer and then it will be taken up by the upper system components or by the subsystems that are present in the operating system. Very similarly, even writing to the disk, it can be written into a buffer, and then from there it can be written to the disk. So, you have components for that in the I/O subsystem, and very similarly you can have device drivers in the I/O subsystem. That is, whatever you write to any device, any output device, that will go through the device driver. The device driver will take care of the writing. Very similarly for input device, input as well. And the next is secondary storage management. Secondary storage in the sense like you have disks are generally being used for a secondary storage. The programs or the processes that are running will generally be present in the main memory during execution. But these processes need not be present, cannot be present in the main memory always, or you cannot place all the processes or the programs in the main memory at a particular time, because the main memory space is very small. And the other thing is the main memory is volatile. So, once power goes off, these programs will not be present in the main memory at all. So, main memory being volatile and being small in size, we need support for placing these programs and processes. So, for that we have the secondary storage device. So, secondary storage device, they help as being a backup. So, you can place whatever process or the programs you want in the secondary storage device. It can either be like programs being placed as files in the secondary storage device, or it can also even be like partially executed processes being placed in the secondary storage device. Okay. So, with respect to secondary storage management, the OS does free space management, it does storage allocation, it does disk scheduling. So, what is free space management? You have disk space that is free, in the sense you have a number of blocks in the disk, or the disk is made up of a number of blocks. Whenever you are storing information into the disk, you will put them in a number of blocks. So, and after some time, say the files have been deleted, that those blocks will become free, and so on. So, you will have free space here and there in the secondary storage device. So, there needs to be someone who takes care or who keeps track of which space is free in the secondary storage device. That is done by the operating system. So, free space management in the disk is done by the OS, and then storage allocation. There are, as I told you, there are a number of free spaces in the secondary storage device. Now, a file has to be put into the secondary storage device, say a file has to be put to the disk. You are creating a new file, or you are copying a file and you are trying to put it into a disk. There should be someone who decides where in the disk this particular file has to be put. That is being done by the OS again. And then disk scheduling. Say you have 5 processes that are currently running, and 5 processes need to write to the disk. As I told you, writing to the disk is slow, or I/O is slow compared to the CPU's execution speed. So, this writing to the disk by all the 4 processes have to be done one after the other. So, in what sequence will this be done? Which process should be given a higher priority? That is being decided by the operating system, and that is called disk scheduling, or the way in which the disk is scheduled among all these 4 processes that are waiting to write to the disk is done by the operating system, and it is called disk scheduling. And then we have networking. So, all the other features that we had seen till now are with respect to operating systems which are specific for a standalone machine. But now, when we have a number of machines that are connected together in a distributed environment, then in that case you have this networking concept coming into picture. So, a distributed system is nothing but you have a number of processors which do not share memory or do not share a clock, or basically it is like having a number of machines that are connected together. So, each processor will have its own local memory, and the processors are connected together using some communication network, and the communication takes place using a protocol. So, in this case issues related to networking have to be designed, like say message routing, the connection strategies, problems of contention, many people contenting to use a particular network, then security in the network and so on. So, all these have to be taken care, and because you have a distributed system you can share resources, and because of sharing resources you can have computational speed up, you can have increased data availability, and you can have more reliability. And if you look at networking or network access by an operating system, it is also very similar to how file access is being done. So, when you have network devices, these network devices can be accessed by the OS by using a device driver, and very similar to how say files are being written on read, you write into the network devices and read from the network devices. And then next is protection system. So, you have number of programs and processes that are running in the system, and these processes have to be protected from one another's activities. Say you have 5 users and the 5 users program and processes are running in the system, then one user should not write into the other user's program and so on. So, you need to have mechanisms for this. So, for that you need to have hardware support as well. So, if you look at memory protection, look at this diagram, you can have multiple programs present in the main memory. This monitor is nothing but the OS that is present in the main memory, and then you have 2 registers. So, for job 2 there is a base register and a limit register, and the contents of the base register is loaded as 300040, and the contents of the limit register is loaded as 12900. So, that is the address, the starting address for this second job 2 is this, and the limit is that it can go only till 300040 plus 1,20,900. So, that is the highest address that is possible for job 2 is 4,20,940. Okay. So, in this case, so you can see here that there is a limit within which this particular job can work. So, loading into this base register and the limit register is done by the operating system. So, whenever a process is taken for execution, the base register value and the limit register value is loaded by the operating system. So, whenever an address is generated, it is checked if it is within the limits of that particular process, and hence memory of other programs and processes are whenever a process is taken for execution, the operating system loads into the base register and the limit register, and whenever an address is generated, it is checked if it is within these limits, so that it will not corrupt or write into other programs memory space. Okay. And then you have something called a dual mode operation. This is very important and it is being used in many of the operating systems. So, here what is done is that there are 2 modes of operation that is being defined, called the user mode and the kernel mode. And there is something called a mode bit which is present in the hardware, which is set accordingly based on whether it is user mode and kernel mode. So, if it is user mode it is set as 1, if it is monitor mode or kernel mode it is set as 0. This monitor mode has got different other names as well, like kernel mode, system mode, etc. and so on. And whenever a process is taken for execution, initially it will start running in the user mode, and when say there is a call to the operating system, say for example, say operating system's code has to be executed as a part of this program, then in that case it will switch to the kernel mode or the monitor mode. And say for example, some IO has to happen, IO instructions are executed only in kernel mode or monitor mode, and certain privileged instructions are also executed only in kernel mode or monitor mode. So, because of this you protect the operating system's code, or basically whenever operating system's code is to be executed as a part of this program or process, there is a switch that happens or system switches to the kernel mode or the monitor mode. So, because of this the OS code is saved or it is protected. And then we have the final thing, that is the command interpreter system. So, this is actually the interface between the user and the operating system. So, this is a program that runs whenever it can either be a special program that runs whenever a job is initiated, or it can be when the user first logs on to the system, or it can be a part of the OS which is included in the kernel. Say for example, in Unix it is actually the shell, okay. So, which is being invoked whenever a user logs on, whenever the user first logs into the system, and the user can give commands to the shell, and the shell will in turn interact with the operating system and execute those commands. Or it can be like the GUI that we have in Windows or Mac kind of systems. So, this command interpreter which takes commands and gives to the operating system and gets back the input from the operating system and gives back to the user, can either be a part of the operating system, or it can be a standalone thing which is out of the operating system and help the users and the OS. So, many commands you can give to the operating system through this command interpreter. You can give commands for process creation, management, IO handling, main memory, secondary storage management, file system access, etc. and so on, for protection, for networking. So, many of these jobs, the commands that you give to the operating system can be given through the command interpreter. So, I will summarize whatever we have learned today. So, today we learnt about the different components of an operating system and the different functionalities, like say we learnt about process, what a process is, what process management is, and different functions of the OS related to that. We learnt about main memory management, we learnt about secondary memory and managing that, about files, about IO systems, about protection, and about the command interpreter that is used to send commands. So, all these are the different components of an operating system, and we also learned what are the different functions of the operating systems with respect to each of these components.